Welcome everybody to episode 6 of Games with Go. And I know a lot of people have been eager to start doing graphics, so today we're going to take the first step towards that and get SDL2 set up. So a lot of people have heard of SDL2, and a lot of people think that maybe it's a game framework or a game engine. It's really neither of those things. It is really like an operating system abstraction layer. So if you want to make a game, you typically need to do things like draw pixels to the screen, play sounds, get input from keyboards, mice, controllers, touch screens, and read from files. You might want to communicate over the network. All these things touch the hardware, and on modern computers, you cannot normally touch the hardware directly. You have to ask the operating system to do all of these things. And every operating system does it differently. So if you wanted to make a game that ran on, say, 3 operating systems, you would have to write your platform layer, the thing that does the low-level actions for all these types of things, 3 times. And if you wanted to target 5 operating systems, you'd have to do it 5 times. Now, most languages will do some of these things for you in a cross-platform way. Like if you want to read files in Golang or almost any other language, you don't have to talk directly to the Windows API or the Linux API. The core libraries have functions built in that will do it properly on every operating system for you. But for some reason, most languages do not have good functions for drawing pixels to the screen, playing sounds, or getting inputs from controllers, and sometimes not even a good way to get input from keyboards or mice. Why don't they do that? I don't know. I feel like they should, but they don't. So we do have SDL2, which provides these sorts of things for us, and some more on top of this. There's some threading and some other things too. But SDL2 is designed with games in mind, and so they make sure that the ability to draw pixels to the screen and play sounds gives you enough low-level control and has low enough overhead that you can use it for games. Because if you have to have a lot of overhead in every frame, things aren't going to work. So that's what SDL2 is. It's like a cross-platform operating system abstraction. So instead of calling operating system functions, you call SDL2 functions, and then you have the appropriate library installed when you distribute your game for whatever OS it's hitting. So you only have to write your code once or approximately once, and it'll work on Windows, Linux, Mac, Android, or even iOS. So this is the SDL2 webpage. I'll put the link in chat. And we're going to want to get the SDL2 development libraries. And you can see that down here. Now, if you're on Windows, you're going to want to get this version right here, the second one. So you go ahead and click on that and start downloading it. And you're also going to need something that can unzip tar gz files. If you don't have anything or you're not sure, you can use WinRAR, and I'll put a link to that as well. And you can start downloading that too. And while people are downloading this stuff, did anyone make a text adventure after last episode? They wanted to share a gist of it, and we can play through it. If anyone did, just paste it in chat, and we'll check it out. All right, once this stuff is installed, the next thing we have to handle is a way for Go to talk to this library. This is a library developed in C, and fortunately, almost every language has a way to communicate with C libraries, and Go is no exception. But in order to talk to SDL2, you either have to make your own bindings to that library or use someone else's. And fortunately, someone has a good binding to SDL2 in Go already. This is the GitHub link for it. I'll paste that in chat also. And we are only going to, for now, use this base SDL2 library. There are some optional libraries you can also install that give you functions for doing things like loading images, drawing fonts on the screen, and some basic graphics primitives. Oh, and if you're on Linux, you can install development libraries with this command. And I think you'll need to type sudo before you type that. And if you're on Mac, that command. All right, so on Windows, there is a gotcha, which is that whenever Go builds a project that talks to a C library, Go also requires that you have a C compiler installed. And on Windows, that's a little bit tricky, but we can do it. So what we'll need to install is this Mingw package. And basically that includes GCC and a few Unix tools that go along with it. It's kind of like you get a Unix-like environment set up within Windows. So if you go ahead and click on this link, and then click on through to SourceForge, you'll get an installer you can go ahead and download. And let me put the, I don't know if that link will work directly. I'll put it in chat and you can try it. All right, once that has finished downloading, go ahead and run it. We'll go next. And you can leave version alone. You'll probably want to change this to x86-64 unless you know that's not correct for you. And you can leave everything else the same. And then if you want to, you can change this destination folder. I'm going to just to make it a little shorter of a path. And then go ahead and start installing it. And once once this is set up, it'll be useful in general for programming in Go because there are lots of libraries that may have a dependency on a C library. So eventually you'll run into a case where you're going to need this setup anyway. So now it'll be ready. You only have to do this once. All right, I'll wait a little bit for people who don't have SSDs because that may take longer. I'm going to open up another Explorer. So you want to go to the directory where it installed, and you'll drill down a little bit. And what you're looking for is this folder here. Open that up. And then open up the development libraries that we downloaded earlier. Oh, and I think I forgot to mention, if you're on Linux, this whole step is unnecessary. You're almost certainly going to have GCC installed already. And if you just type GCC and hit enter at a terminal, you can confirm that. If it exists, you'll see it spit out some output. So if you're on Linux, just hang tight. Your life is easier. All right, so if you open up this archive and drill down into here, and then drill down into this folder if you're on an x86 64-bit machine. Now what you want to do, you should have this folder in your MGW installation open. Just take all of these files, highlight all of them. You can control click and drag them all over into here. And it's just going to add all of these files into this tree. And this basically puts the development libraries in a place where the GCC compiler knows where they exist. So that's basically installing SDL2 on your system. All right, another step, we need to set environment variables. So if you start typing environment in the start menu, then you'll see this edit system environment variables pop up. You can click on that. And then down here in system variables, look for path. And what this path does is whenever you're typing things at the command line, it will check every path listed in here to find executables that match. So click on path and then hit edit. And this shows you a list of all the system, all the environment variables you have set up so far. So I had a couple from before I deleted everything. So I'm going to clear those out. All right, so we're going to have to add 2. So let's click new and add our first one. And the first one we want to add is this bin folder right here. So right where we copied the SDL2 stuff. And you can see the SDL2 DLL right there. So we want that to be in our path. So let's hit new, and then you can just paste. You can copy from up here, paste in down here. And then hit OK. And let's edit again. So the second path we need to add is a path to where GCC is. So if we go like all the way back out to where you installed MinGW, drill down into that first folder, and then into MinGW64, and then to the bin folder, and you'll see there's a gcc.exe here. So click up there so it's all highlighted, Control C, new path, Control V to paste it in. So now we're going to have GCC on our path and the SDL2 DLL in the path. So hit OK, OK. And now what you'll need to do is any command prompts you have open, or if you have VS Code open, go ahead and close it and reopen it. Because you'll need to restart it for it to be aware of the new path variables that are set up. Okay, let's see if I am forgetting anything. I don't think so. Is everyone caught up so far? I know it's a lot of steps, so if anyone's having trouble, let me know. We'll work through it. All right. So let's actually start a new program. Let's make a new folder. We'll call it just SDL2 for now. I made that in the wrong place. Drag it out. And then inside, let's make a new file, SDL2.go. All right, so what we're going to do is start out with just a minimal program that opens a window, so we can see how we use it, how we use SDL. So package main, and then we're going to import github.com/vianco/go SDL2/SDL. Then we're going to have a func main. So to make a window, we call a function called create window. Sorry, I had to turn my headset back on. So create window takes a few parameters. It takes a title for the window. That's the thing that would show up like up here. It takes an X and a Y position for your window, and you can set those explicitly or you can just leave them undefined. And I believe Windows just decides where to put it in that case. And that's a built-in constant for undefined there. Then we need a width and height. So let's do 800 by 600 to start out. And then we can set some flags. We're just going to do SDL window shown. Window position. Window position. Okay. All right, now this may look weird to you. I don't think we've shown this yet. One feature that Go has is that Go can have multiple return values. So rather than a function just returning one thing, it can return more than one. And this is sort of how Go handles errors. Rather than having exceptions or other techniques, the pattern or convention in Go is if you have a function that can potentially have an error, then you return two values. You return the result and you return an error type. And if there is no error, you just set the error type to nil. So to check if an error happened after calling a function, immediately after the function, you say if error is not equal to nil. Okay, so if this evaluates to true, it means you have an error. And then you can print that error using format.println. Like that. And then we can return to cancel our program if we want to. Okay. So now we're asking SDL to create a window, which will call the appropriate operating system calls, depending on what operating system we're on automatically. And we're checking for an error. And I think that should be enough to see if anything happens. We don't want the program to close right away. So we can call a function built into SDL2 called delay that accepts a time to wait around in milliseconds. So that'll wait for 2 seconds. And then we need to actually use the window. Do we need to do anything with it? No. All right, so we're going to introduce another Go feature here, which is a built-in keyword called defer. So in SDL2, if you want to close a window and clear up all the resources it was using, you need to call the destroy method. And what defer does is defer will run this function once this function ends. So in this case, it would be easy to just say Windows destroy like that. But you can imagine once we have like a big game loop here, it might be hard to remember that you need to call window destroy when you created it way up here. And so by using defer, you can keep it right up here. and guarantee that it's going to get called when this function exits. Another point here is this is not strictly necessary in this case, because when this function completes, when the main function completes, the entire process is going to be destroyed anyway. So this kind of thing is normally not necessary. Some people choose not to call it because the program can close quicker. All right, so let's go into the SDL2. And one more step to get set up is we need to actually get this package, because this is not built into Go. We need to download it. And the way you can do that is you use go get and then give it the full path like that. Then we can say go run sdl2.go. Let's see what happens. All right, so we got a window for 2 seconds, and it had our title in it. Are there any questions so far, or is anyone having trouble so far? Okay, now that we have a window, we want to be able to draw things on it, so we can do some graphics programming. And what we need is something called a renderer. So we create a renderer in a similar way to creating a window. We call SDL create renderer. And a renderer is going to be associated with a window. So we'll pass it the window we just created. Index we're going to set to -1 for now. And accelerated means that it can use our GPU if we have one. If you don't have a GPU, you might need to say software. But most newer or even slightly old Intel CPUs have a GPU built in. So if you're not sure, give it a try. And then again, we need to check if we got an error. And if we did, print it so we can see what happened. And then exit. And then renderer needs to be destroyed when you're done with it, just like a window. So we'll call that. All right. Okay. Next step is we need to make a texture. And we'll see that texture follows the same pattern as, oh, is that right? Yeah. As the last two things. I'm going to create a texture. And the first parameter is a pixel format. So pixels can have a lot of different formats. Basically, what you want to think of is an array of bytes in memory. So it's just going to be numbers between 0 and 255. Like that's what that's what your screen is as far as the computer is concerned. But you need to tell SDL2 what kind of layout you're using for the pixels on the screen. And there are different ones, but a common one is to have like red, green, blue, alpha. Alpha is an indicator of how transparent the pixel is. So then something like 255, 0, 0 would be red. Because red is maxed out, green and blue are 0. If you maxed out everything, that would be white, because you're lighting up all the pixels all the way. So we're going to use pixel format. You can see there's lots of them here. ABGR 8888. And that's where you're basically going to have 1 byte for each of red, green, blue, and alpha. Then there is a setting for how the texture is going to work. And we're just going to set that to streaming for now. And then I believe it's width. Yeah, width and height. So we'll do our 800 by 600. And then let's go ahead and make this variable so we don't have magic numbers. And so these are going to be int32s by default, and we might want to use them that way. And SDL2 these will be ints, sorry, and SDL2 is going to expect int32s. So we're going to cast these to int32s. We'll do the same thing here. All right, what do we create texture? Oh, this is on the renderer, not SDL. ABGR. Forgot the underscore. All right, and we need to check for errors as always. It's really a good idea to do this because if you get some problem and you just end up with a black screen, you won't know what's going on. If you check for and print the error, then you have a chance. Okay, do we need to destroy the texture when we're done? Yeah. All right, we've got a window, a renderer, and a texture. So in order to draw things, we need pixels. So let's make some pixels. So pixels, we're going to treat as a byte array. And we are going to make a slice of bytes, the same size as the window width times the window height times 4. So let me explain what that is all about real quick. I think it's just mad because win height. Okay. So the way drawing to the screen works is you have a buffer, and a buffer is just, you can just think of that as an array. So you've got your, whoa, what did I do? There we go. A buffer is just an array. Let's do a better job of drawing. Right, it's just contiguous memory. Let's see, 3, 4, 5. Let's do 6, 7, 8, 9. 2, 3, 4, 5, 6, 7. All right, let's say we have an array that's 9 long. Right, from 0 to 8. And let's pretend we have a really old computer where the resolution is just 3 pixels by 3 pixels in a square. Like this. So the way that our buffer maps to the screen is basically like this. The 0th index of your array will be here, and then 1, and then 2. And once you hit the edge, you go back over here. 3, 4, 5, 6, 7, 8. Right? So you just put the colors you want. Red, blue, yellow, white, whatever. Uh, in each element of the array, and that maps onto the screen like this. 0, 1, 2, 3, 4, 5. So it's just a big contiguous chunk of memory because that's the fastest way that you can read and write things. It's memory. It's when it's contiguous. And then this just maps onto the screen like this based on the resolution. Okay, so we're making an array. The reason it's win width times win height is if our window is 3 pixels by 3 pixels, then we need 9 colors for each screen. And the reason we say times 4 is because we chose a pixel format that contains 1 byte for alpha, 1 for blue, 1 for green, 1 for red. So we need 4 bytes for each pixel. So that's where this comes from. All right. So let's see if we can actually prove that we're drawing anything. Let's create a function that will draw a pixel. That is like the simplest possible function, and everything else will follow from it. So let's call it setPixel. And this will take an x and a y for the position of the pixel. And those will both be ints. And then we'll take a color. And let's make a color struct. So let's say type color struct, and we'll have RGB, and those are all bytes. And if I don't know if we've shown this syntax before, but if you're declaring multiple variables that all have the same type, you can do it like this, where you just separate the names and then just say byte once. And we can do that in function signatures as well. Okay, so we have x, y that are both ints, and then we're going to have a color, call it C, and then we're going to take our pixel array, or pixel slice, and so what we want to do is, given an x and a y, we want to compute the index into this array that we need to set, right? We're converting from some xy position that we're thinking about on the screen and compute the index into this array from 0 to however big it is. So that's easy to do. You take y times the width of the window. Ooh, and we have these, let's make these constants that everything can see for now. So we'll make this const when width, when height, 800, 600. Okay. And then up here, so we take y times the window width plus x times 4. So basically what we're saying is if y were 1, for instance, like right here, it's y of 1, then we know we need to jump to the second row. So we multiply times the width of the screen. And then whatever x is, you add. So if x were 2, for instance, then you would add 2 to jump over along the row. Then we need to set the color. So the first byte signifies the red component. So we can say c.r is red. The second byte, so we'll just move forward in the array by 1, is the green component. And we move over 1 more, and that's the blue component. And for now, we're just going to ignore alpha, but later we may set the alpha as well. Let's see, what are we unhappy about? Pixels. All right. Another thing we probably want to do is make sure that the index is within the length of pixels. So len is a built-in function that can take a slice and tell you how big it is. And we need to leave enough room for all 4 bytes that we're going to set. And make sure the index is greater than or equal to 0. So by having a check like this here, you can imagine if you were drawing something on the screen and it floated off so that half of it was off the screen, then this would continue to work. If you didn't do that, you would get a runtime error because you would try to index a value that's outside the value of this arrange. And Go checks array overruns and will halt if you do that. All right, so we have a function to set some pixels. So let's try using it. So let's do a loop. Let's just loop through the whole pixels array. So we're going to do for I in the range of pixels. Oh, we could just do it like this. Right. So for each valid index in the pixel slice, let's say we're going to use set pixel. So we'll do it like this. For y is equal to 0, or let's see, range. Let's see, what's the best way to do this? Y equals 0. Y is less than when height. Y plus plus. And for x is equal to 0. X is less than when width. X plus plus. Let's set pixel x comma y to color. Let's just make it red. So we'll do 5500, and we'll pass our pixels slice. Okay, that fills up our byte array, but that is not enough to draw it. There's a few more steps. Because so far all we've done is make an array of pixels. We haven't associated it with our texture at all. So to do that, you call text.update. We're not going to use the rect right now. We give it the slice we want to use, and then we give it the pitch. And pitch is basically the width of the screen times how many bytes per pixel. So pitch is this. It basically tells SDL2 when you're going to the next row. So that's our pitch. And then we call renderer.copy with our texture and renderer.present. Let's see what's unhappy here. Okay, that should be enough to draw a red screen. So let's give it a try. There we go. We have drawn red. Congratulations. All right, is anyone following along having any problems or have any questions about this so far? All right, let's make this a little more interesting, just to play with it a little bit. We can do something like, let's see if it'll, hmm. Can we do this? All right, that's a little more interesting. So all we're doing here is taking the modulus of x over 255. So what that means is as x gets bigger, once it hits 255, it's going to start over again, wrap back around to 0, count back up to 255. So that's why we get that kind of checkerboard pattern with red and green being mixed together in different ways, depending on where you are on the screen. All right, there's a lot of infrastructure work to get everything set up, but now we are good to go. We have the ability to use SDL2. That gives us access to the ability to drawing to the screen, playing sounds, reading input from controllers, from mice, all sorts of stuff. And we've got the basic setup to start drawing pixels. And so what we can do next, I'm thinking probably next episode we'll make Pong, which was one of the first video games. And that'll let us get used to doing some very basic graphics, because pretty much all Pong has are some rectangles and a circle, as well as getting input from controllers, mice, and keyboards. And we'll start our first game loop so we can actually play it, and we'll have a little very simple AI for the computer to play against. And then we'll start building from there. So yeah, I think next episode we will use what we've set up here to recreate Pong with nothing but our set pixel as a primitive. We'll build up from here to get it done. All right, I think that's going to be it for tonight. There's a lot of stuff here. If anyone has trouble who's watching this when it's not live, feel free to send me a note on Twitter or something. People who are on Mac OS might have some troubles that we haven't gone over here, and we'll try to sort them out. And if you want some homework to do, draw some crazy stuff. And if you come up with anything cool, you can create a gist next week, and I'll show it off on stream. All right, that's it for tonight. I will be back, should be back Tuesday. We'll show off anyone's crazy graphics and start making Pong. Good night for now.